Hello everyone, this is Eddie and I'm here to teach you how to compute loads using the Philippine Electrical Code 2017 standard for dwelling unit. But before we proceed to the computation, first we should familiarize this table from Philippine Electrical Code. For our sample computation, we have here a sample floor plan of a dwelling unit. First, we must determine the total area of the unit. To do that, just multiply the length and the width of the area. So here, we have a length of 7 meters by 11.725 meters. So that is equivalent to 82.08 square meters. Next, determine the small appliances and major loads such as air conditioning unit, electric range, heaters, and so on. For the dwelling unit, it is common to use one circuit only, which is equivalent to 1,500 VA. And also here, we have listed our major loads. For the bedroom 1, bedroom 2, and bedroom 3, we have 1/2 HP ACU. And for the dining area and living area, we have 1.5 HP ACU. And for the kitchen, we have an electric range that has a rated power of 1,500 volt amperes. Now, we can proceed for the load computation. For the load computation, first is the general lighting. To compute this, we will refer to the table 2.20.2.3 of the PEC 2017. So here we need to identify the volt amperes per square meters of our type of occupancy. As we can see in the table, dwelling unit is 24 VA per square meters. Then compute the general lighting by multiplying the total area to the 24 VA per square meters. So we have 82.08 for our area multiplied to the 24 VA per square meters. So we will cancel the square meters. So that is equivalent to 1,969.8 VA. Then, input the small appliances load, which is 1,500 VA. Then, sum up the 8.1 and 8.2. So, we have a total of 3,469.9 VA. Next, we will apply the demand factor. By the way, demand factor is the ratio of the maximum load used by the circuit over the full load capacity of the circuit. So to apply this one, we will refer to table 2.20.3.3 of the PEC 2017. So here in the table, the first 3,000 VA for the dwelling unit should have 100% demand factor. Then from 3,001 to 120 VA, which is equivalent up to 117,000 VA, should have 35% demand factor. And above 120,000 VA should have 25% demand factor. For example, we say from our load computation, we get 150,000 VA. Now we will divide the total power into three parts. First is the first 3,000 VA. So let's say this is the first 3,000 VA. Okay. Next, from 3,001 to 120,000 VA. Let's say this one. From 3,001 up to 120,000 VA. So that is equivalent to 117,000 VA. Then lastly, the 120,000 VA above. So here, 120,000 VA above, that is equivalent to 30,000. So this is the remaining power from 120,000 VA. So if you want to check if this is correct, just add the 3,000, 117,000, and the 30,000. It should be equivalent to 150,000 VA. Next, we will apply the demand factor. So for the first 3,000, let's input the 3,000. Then the 117,000. And lastly, the 30,000. Then we will multiply this with their respective demand factor. So 3,000 times 100, that is equivalent to 3,000. Then 117,000 times 35%, so that is equivalent to 40,950. Then 30,000 times 25%, that is 7,500. Then sum up all the power. So we get 51,450 VA. Now let's apply this process to our load computation. Here at 8.4, let's input the first 3,000 VA. Okay, next. At 8.5, input the remaining power. So the remaining power would be 469.9 VA only. And then, for 8.6, since nothing has left, just input 0. Then multiply with the respective demand factor. So 3,000 times 100%, that is equivalent to 3,000 VA. Then 469.9 times 35%, that is equivalent to 164.47 VA. Then 0 times 25%, that is 0. So after that, we can now get the total load for lighting and small appliances, which is equivalent to 3,164.47 VA. Okay, so we are done with the general lighting and small appliances computation. Now let's proceed to the computation of our heavy loads or other loads. First is list down all the loads that we determined a while ago. So we have 1.5 HP ACU. Then we have also here 3 1/2 HP ACU and 1 electric range rating 1,500 VA. To determine the power rating of our air conditioning unit, we will refer to table 4.30.14.2. Since our voltage is 230 volts here in the Philippines, we will identify the current of our ACU at the column of 230 volts. For example, at 1.5 HP, its current under 230 volt is 10 amperes. Multiply the current and the voltage, we will get the power rating of the ACU, which is equivalent to 2,300 VA. So just multiply the voltage and current, and we will get the power rating of the ACU. Next, for the 1/2 HP, it has 4.9 amperes. So, we will multiply that to 230 volts. We will get 1,127 volt amperes. Then multiply to 3 units. So times 3, we will get a total of 3,381 VA. And for our electric range, we have 1,500 VA. Then sum up the total load we will get 7,181 BA. So that is the total load for our heavy loads and other loads of the circuit. Now that we are done computing the total load for lighting and other loads, we can now get the overall power of the house. So to do that, just add the A.7 and B.4. For the A.7, we have 3,164.47 plus B.4, 7,181. So we have a total of 10,345.47 VA. Okay, now compute the total current of the system by dividing the total power to 230 volts. So we have total power over voltage. And that is equivalent to 44.98 amperes. Through the value of our total current, we can now choose the size of conductor by referring the table 3.10.2.6 of the PEC. For the minimum size of conductor, choose a wire that has an ampacity closest and higher than the total current. Since this is the wire also for our service entrance, we can choose THW, which is good for wet and dry season. Under the column of THW, the closest and higher than the 44.98 ampere is the 65 amperes, which is the 8.0 square millimeter conductor. Therefore, we will use two 8.0 square millimeter THW copper wire for our feeder. Now for the grounding, let's refer to the table 2.50.6.13. The closest and higher than the 4.98 amperes is 60 amperes, which is the 5.5 square millimeter copper wire. Therefore, we will use 5.5 square millimeter THW copper wire for grounding. Okay. Then lastly, for the circuit breaker, since its main purpose is to protect the wire from overheating due to large amount of current, its rating should be less than the current capacity of the feeder. The feeder has an ampacity of 65 amperes. Therefore, we can use 60 ampere trip breaker, which is available to the market. Okay. And that's how we compute electrical loads using PEC standard for dwelling units. I hope this video helps a lot to you. And if you like this video, please hit the like button and don't forget to subscribe. If you like to learn the techniques in solving mathematics and electrical engineering problems, just tap the bell icon so you will be notified for my next tutorial. Again, this is Eddie, hoping to see you on my next video.